Hey guys, I hope you all are doing well. So today's our aim is to solve problems in electrical engineering. Okay, so let's get started, guys. So for the first question out here, I have something like this. So I've given a current time graph. So there's a current time graph out here. And we go something like this out here. Yeah, it's a straight line out here. At this point, the current is 6 amps out here. Okay. At this point, the time is 2 seconds, and we have somewhere around 4 seconds over here. Okay. So current passes through an inductor so the current passes through the inductor, and its resistance is, sorry, you can just tell the impedance of the inductor. ZT is 1 ohms. Inductance of coil L is equal to 2 Henries over here. Cool, guys. So now we're interested in the energy absorbed in the inductor in the first 4 seconds. So we're interested in the energy absorbed by the inductor in 0 to 4 seconds. Okay, cool, guys. So we know a basic formula, which is power is work done by time taken, and for electric circuit it just becomes energy divided by time taken, T out here. Okay, so the energy is nothing gonna be but integral of P times dt over here. Okay, now we know P equals VI. Okay, so also voltage across the inductor is L di by dt. Okay, so let's just try substituting in P. So therefore P is just gonna be L Li di by dt. Okay, it's L into I di by dt over here. Okay, so it's Li di by dt. Okay, so E is just gonna be integral of Li, and we have di over here divided by dt times we have another dt over here. So let's just try cancelling these two terms out here. So energy is just going to be simply equal to integral of L I di. Cool, guys. So out here in this question, the energy is from 0 to 2 and 2 to 4. Okay, so energy E is equal to 0 to 2 Li di plus integral of 2 to, I guess it's 4 sec Li di. Okay, guys, so what we can try and do out here is now just take energy E out here. Let's just try integrating things. So it's half Li square 0 to 2 plus half Li square 2 to 4 over here. So the energy E is just going to be half the value of L over here is 2 Henries over here. Okay, so it's 2 Henries. Let me just write it as 2, and the value of I over here, the value of I is, I guess, 0 to 2. Okay, so it's a 2 square minus 0 square. Okay, plus half over here times the 2 Henries times this 4 square minus 2 square over here. So E is just going to be, you can just cancel these 2's over here. So it's going to be 4 plus 16 minus 4 over here. So it's just going to be 4 plus 12. So it's just going to be 16 joules. Okay. So it's 16 joules over here. Okay, so this is the energy of the inductor over here. Now we are interested in finding the energy of resistor over here. The energy of resistor is nothing but I square RT. Okay, and let's just try write it out in integral form. So you can just rewrite things like integral of I square R dt over here, and the integral goes from 0 to 4 seconds. Okay, so it's just going to be like before we proceed, we like changing some things out here. So okay, the current, I wish he has given the current in the circuit over here. Okay, he has given 6 amps over here. So resistance R is 1 ohm. So we are also interested in the current, so it's, let the integral go from 0 to 2, and we have I square R dt plus 2 to 4 I square R dt. So now we are interested in finding the value of current, since things are not constant out here. So let me see what I can do. Okay, so he has given us a special case, guys. The case goes something like this out here. So I is just 3t over here. Okay, and for 0 is less than equal to t is in between 0 to 2, and I is equal to a constant which is equal to 6 for t to be in okay, so let's try finding e of r over here. So e of r is just gonna be 0 to 2, and I square is 3t. The value of resistance over here, r is 1 ohms. Okay, so that's a 3t out here, and okay, it's 3t the whole square times dt plus you just go integral from 2 to 4, and it's 6, and it's dt 6 square dt. Okay, so e of r is just gonna be 9 t square dt. Let's just integrate this, and 36 dt over here. Okay, so e of r is just gonna be 9 t cubed by 3 over here. It's gonna go from 0 to 2 over here, plus it's just gonna be 36 dt over here. Okay, it's 36 t over here. T goes from 2 to 4. Cool, guys. So e of r, let's just try substituting values. So it's going to be 3 out here, and it's 2 cube plus 36, and it's 4 minus 2 over here. So e of r is just going to be this 8 into 3, it's 24 units, and out here is 36 into 2 is 72 units over here. So it's just going to be 70, and 2 is 96 units. Cool, guys. Okay, so the total energy of the system is just going to be adding these two quantities out here. Okay, the quantity which we got out here is 16 joules out here. So let's just see if we aren't wrong anywhere out here, So half Li square. Okay, we are wrong in terms of taking time t out here. We are interested in the current quantity over here. So the current out here goes from 0 to 6, and out here is constant. Okay, so let's go from 0 to 6. So it's 0 to 6, guys. So I've done a pretty small mistake out here. So out here, my limits have gone wrong over here. Okay. So let's just try rewriting the limits over here. And we are interested in modifying the final answer over here. Okay. So by mistake I took the time limit. So out here we have, I guess, it's 0 to 6 amps out here, and it's from 6 amp to 6 amps out here. Okay, so this term is just going to go to 0, and this term is 6 square out here, so it's 36 out here. It's 36 units. Okay, so the total energy in the circuit is just going to be E of R plus E of L, which is 96 plus 36 out here. Okay, units, or let's make it to joules. Okay, guys, so cool. Let's go try solve another problem out here. So before I can do that, let me see if there anyone in the chat out here. Okay, so the next problem is just going to be this one out here. So we have a resistor over here, and we have a capacitor over here. We have an inductor over here, and we have a current source over here. Let's name these 2 points as PR. 5 ohms out here. This is V of R over here. This is V of L over here. The current in this part of the circuit is 1 ampere. Out here the current source is of 2 amperes. That's 2 henries out here, and it's 1 farad out here. Cool, guys. Also they have given V of R is equal to 5 volts, and V of C is equal to 4 sine 2t. We are interested in finding the voltage across the inductor. Okay, so what you can try and do out here is just use Kirchhoff's current law. So our aim is to find V of L. Okay, so out here, you know, guys, there's a current due to the capacitor, there's a current due to inductor, and there's also a current source over here, you know. So we have 4 currents here. Okay, so out here V of L and V of R in opposite directions. Okay, so let's do one thing. We can just rewrite it as 1 ampere minus the current due to the capacitor, and is equal to V of L minus V of R. So you can just rewrite it as V of A minus I of C plus we have V of R is just going to be equal to V of L over here. Cool, guys. Now we know Q equals CV for capacitors. Okay, so let's just differentiate with respect to time t out here. So you're just going to get C times dV by dt over here. Okay, so now out here dq by dt is just going to be the voltage across the capacitor. So now we have a formula for the voltage across the capacitor out here. Okay, so let me just draw a small line out here. So we have a small conclusion out here. So 1 minus C times dV by dt plus V of R, the voltage across the resistor is just going to be equal to V of L. Okay, so the voltage across the resistor is nothing but I times R. So let me just try writing that down. T plus the current I out here is 1 ampere, and the resistance is 5 ohms. So it's just going to be okay. So we are interested in finding the current out here, you know, guys. So let me just rewrite things down out here. So it's plus I of r equals I of L over here, and out here it's the same thing. So I of r is equal to I of L over here. So I of r is 5 divided by 1 ohm. Okay, so it's just going to be 5 is equal to voltage across the inductor divided by the impedance of the circuit out here. Okay, so let's just leave it to I of L over here, initially. Let's see if we can modify it later. Okay, now the voltage across capacitor is nothing but 4 sine 2t. Okay, so the current across the capacitor is going to be equal to C times dV C by dt. We know the value of C, which is 1 farad out here, multiplied by 4. Differentiation of sine is nothing but cos 2t, and you multiply it with 2 over here. Okay, so I of C is just going to be equal to 8 cos 2t. Cool, guys? Okay, so let's just try substituting things out here. So out here we have 1. Okay, sorry guys, this is 2 amperes out here, guys. I've done a mistake. Okay, let's just not consider this out here. Okay, we know I of r is 1 out here. I of r is 1 out here. So there's 2 amps out here. This is 1 amp, this is 2 amps. So let me just try making some corrections out here. So it's current to resistor is 1 amp. So this is I of r. So this is this 2 amps out here. Okay, and let's just make it to 2 over here. So it's all going to be all right out here. So let me just take us at 2 out here and 2 over here. Okay, so what we have now is 1 plus 2 minus 8 cos 2t. This is going to be I of L over here. Okay, so it's just going to be 3 minus 8 cos 2t equals I of L. Okay, guys. So now we know for inductors, we have voltage across the inductor is L times di by dt. Okay, so what we can try and do out here is we are interested in finding V of L over here, and we know I out here, and the value of L over here is 200 out here. So let's just try substituting things. V of L is 2 times d by dt over here, and then you can just put in the values out here. So it's 3 minus 8 cos 2t over here. Okay, so V is just going to be 2 times 0 minus we have 8, and we have a sign out here, we have a positive sign out here again, 2t multiplied by 2. So the voltage across the inductor is just going to be 16. 16 and 2 is going to be 32. So it's 32 sine 2t. Cool, guys. So this is the voltage across the inductor. So guys, I solved these two questions. It was really fun. In the next session we are going to solve some more. So until then, have a nice time.